biggest mistakes that I used to make when learning pure math was taking notes. Professor X with a Z here. I'm here to tell you about some of the common mistakes that I see when people are taking proof-based courses, and some suggestions and helpful tips on how to resolve those mistakes. As always, if you enjoy my content, make sure you follow and share and like and comment so that I know some topics that people would like to hear about next. Obviously, taking notes is not a bad thing when trying to learn material. The issue is how people use those notes. A lot of times they believe that just reading over the notes over and over and over again, or just reading the textbook over and over and over again, or watching lecture over and over and over again is going to help them learn the material. And that's not quite the case. For example, it's like reading the dictionary like word for word and like writing down the meaning of every word. You have the meaning of every word for reference, but the issue is some words don't really have meaning until you use them in context, right? Like it's just like trying to learn slang or something. You have to use it in context in order to master it. That's the same thing with proof-based math courses. The proofs themselves and the theorems and like all of these are just tools to help you solve the problems, right? But the problems and the exercises are where you're really going to learn and appreciate the meaning of these proofs and these theorems and these ideas. The way that I really began to excel in proof-based math courses was when it clicked to me that, you know, these proofs are great for understanding and we can learn, you know, new techniques to potentially implement into our own proofs, but sometimes the proofs contain like highly technical details or things that we may not have come up with within 1 hour when we're, you know, working on a homework assignment, right? Like some of these theorems took years for people to prove. So a lot of the techniques could be contrived or kind of counterintuitive. So that's why it's good to learn and go over them and understand them to your best of your ability, but I would not take so much time on it. That's one of the biggest mistakes that I used to make, was I used to spend like hours trying to understand proofs, and then when I got to the homework, it didn't really matter because I still didn't really know how to do the homework. The point of the proofs and theorems are not for you to, you know, take every detail of them, but they're literally there just to help you solve the problem. I fixed this issue by not really spending so much time on the theorems, proofs, and corollaries, but spending more time trying to learn the material from the problems, because again, those usually are what gets you to ask those questions that you otherwise would not have had to ask with just using the theorems, lemmas, and corollaries. Because again, all of these ideas are just tools to help you solve problems. They're not meant to just be standalone ideas. Going back to the dictionary idea, they're not just meant to be standalone entities like how they're presented in the dictionary. They are a part of a bigger story, and you don't necessarily need to know exactly how they were derived. It's just really important to know why we are using them in the first place. Another major mistake that I see people making when they're starting out with these upper divisional proof-based math courses is that they try to get a little bit too creative on the homework assignments, especially on things like real analysis and abstract algebra, right? Like people start to you know, just start making crazy things. You know, I used to work with friends and we would be spending hours just on these crazy, you know, paths. And usually when we saw the solution, it came down to applying literally just one or two of the theorems that were covered in that past unit, right? And that's one of the things that I learned, was that a lot of times, especially in like early upper divisional and like kind of like introductory graduate courses, you don't necessarily need to be super creative. Like a lot of the problems are not really made for you to like think of some nifty trick or some nifty process. The reason being is because again, that could take years for some people to get, right? The point of these theorems, proofs, and corollaries is literally so that you can apply them to the problem. I would definitely recommend, when you are starting to solve these problems, go through every theorem in the unit and see which one most aligns with the problem. So for instance, there may be some adjectives in the problem, and those exact same adjectives may be used in the hypothesis of a theorem that was proved in class. So you know, okay, potentially we want to use this theorem to solve this question. And then from there, that's when some of the creativity comes into play, because you have to figure out how exactly you're going to apply it. But again, to solve this infinite creativity problem, first identify which theorems, lemmas, and corollaries will be helpful or potentially helpful to solving the question. Thank you again for watching this far. That pretty much concludes the video, and if you all have any more things that you'd like me to discuss, please let me know in the comments. Professor X, what is he out?